reactive intermediate, what does it mean? Suppose you have a reactant, and you have some reagent, you have added some reagent to the reactant, then it will convert into some intermediate first. Intermediate. After forming intermediate, then only it will be forming the product. Okay, so reactive intermediate are those compounds which are not present at the beginning of the reaction, it was not present, and which will not be found after the reaction gets over. But in between, there are some spaces formed, then these spaces are known as what? Reactive intermediate. Okay, now there are four main types of reactive intermediate, types of reactive intermediate. Types of reactive intermediate. The first one is carbocation. The second one is carbanion. The third one is free radical. And the fourth one is the carbon. So carbocation. Cation, I told you, will be having positive charge. Anion will be having negative charge. Free radicals means they will be having one unpaired electron as radical, and carbon will be having, there's a both pair of electron, but its octet is not fulfilled. So let's discuss about this intermediate one by one. So first we'll be discussing about carbocation. Carbocation. So let's take an example. Carbocation means whenever you have positive charge over carbon. Let's take a simple example first. CH, here you have Cl. Now this is a covalent polar bond. The electrons will be shifted towards chlorine because chlorine is more electronegative. Now, because chlorine is more electronegative, if the bond between carbon and chlorine breaks heterolytic, then it will generate H, and this carbon will be now having positive charge because its electron has been taken up by chlorine. Now, this species is known as what? Carbocation. Carbocations are having positive charge, and can you count how many electrons are present here with this carbon? 1, 2, 3, 4, 5, 6. So there are 6 electrons surrounding the carbon atom. So on page number 12.72, the definition of carbocation is given: an organic ion having the positive charge on carbon and 6 electrons in its valence shell is known as the carbocation. So this is an example of carbocation. Positive charge 1, 2, 3, 4, 5, 6. 6 electrons in the valence shell, and this is now known as what? Carbocation. Now there will be many types of carbocation. So let's discuss about types of carbocation. So whenever you have, say, this and to this, so this positive charge, CH2. Now you can see that positive charge is attached to this carbon, and to this carbon is attached to how many carbons? 1, 2, 3 carbons. This carbon, which is carrying positive charge, okay, is attached to how many carbons? 3 carbons. Therefore, this is known as third degree carbocation or tertiary carbocation. Now similarly, if you have only 2 CH3 group and here you have say hydrogen. Now this positive charged carbon atom is attached to how many carbon atoms? Directly it has to be attached. So 1, 2 carbon atoms. Therefore now this is known as second degree or secondary. Now whenever this carbon carrying positive charge is attached to only one carbon directly, and that will be known as first degree, or this is first degree or primary carbocation. Primary. Okay. Similarly, if it is not attached to any other carbon atom directly, which this carbon carrying positive charge is not attached to any other carbon directly, then this is known as what? Methyl or methyl carbocation. This is known as methyl carbocation. So you have to remember, see, tertiary, secondary, first degree, and methyl carbocation. Now, can you talk about the stability of this carbocation? You should be able to tell it easily. Now, since we have discussed about all those effects, inductive effect, electromagnetic effect, resonance effect, hyperconjugative effect, all those effects we have studied. Now, which will be applied here? Here you can see this carbon has positive charge, and if there is more electron donating group donating effect showing groups towards this carbon atom carrying positive charge, then that particular this carbocation will be most stable. So here you can see you have 3 CH3 group in tertiary. So there are 3 plus I effect which enriches this carbon atom. It increases the electron density over this carbon by 3 of the plus I effects. Here you have 3 plus I effect. In case of secondary, you have 2 plus I effect, and in case of first degree, you have only one plus I effect. And here in case of methyl carbocation, you don't have any plus I effect. So to decide the stability of carbocation, you have to see more the number of plus I effect showing group, then its stability will be maximum. Therefore, here in case of this carbocations, tertiary will be its stability will be maximum, then comes secondary group, then comes first degree, and the least stable is what? Methyl carbocation. So this is the stability order of carbocation. Now, if you have some minus I effect showing groups, then in such cases, more the minus I effect showing groups attached to this carbocation, then that would be least stable. Okay, you have to remember this trend. You have to remember this trend and the reason why this trend is followed in case of carbocation. Now, whenever we have, say, benzene ring, and to that, suppose you have CH2 group attached to it, then that is known as what? Benzyl carbocation. You have benzene ring, and to this benzene ring, suppose you have a positive charge. Now this positive charge is stabilized by the resonance effect of the benzene ring. Here it takes place in this form. Okay? So because of resonance, this benzyl carbocation, this benzyl carbocation is very stable. It is more stable compared to even tertiary alkyl carbide. So this effect, you need to draw its resonative structure. Okay, you have to learn to draw its resonative structure. We have CH2. Now, since this double bond has come over here, we have a double bond here, and here you have a positive charge. Then this structure again. Now, what will happen? This will again shift here to neutralize this positive charge. Now, this is how the resonance takes place. You have to learn to draw all these structures. Positive charge here. Here we have double bond. Now this will be shifting to this place. Then again you get another structure. Double bond CH2. You have double bond over here, double bond here, and you have positive charge here. Now this positive charge again will be neutralized by this, and at last you can see that the first compound is regenerated. Here you have double bond, and here you have CH2 again plus. Now we can saw that this positive charge was dispersed over all the carbons in the ring, and this is how the resonance takes place. And because of this, they become very, very stable. And if you have more number of this benzene ring attached to this carbon containing this positive charge, then that will be much more stable. Okay, so you have to remember all these things. These are very, very important. Now let's discuss about carbanion. Carbocation we have discussed. Now for carbanion, it is just the opposite. It's just the reverse because they are carrying negative charge. Carbanion. Now carbanions are what? The carbon containing negative charge. Okay? Suppose here you have this compound, say acetone, CH3, C double bond, you have CH3, you have what? CH, you have CH, H and H, and you are reacting with what? You are reacting with first let me give you an example of carbanion. Suppose you have such groups, say C, H, and some line over here. Now when this bond breaks in such a manner that both electron is taken by what? Carbon. That means this electron is taken by carbon, then you will be getting CH, H, and here you have negative charge, whereas Y will be having positive charge. So this compound containing negative charge over carbon is known as what? Carbanion. Anion means what? We'll be having negative charge. Okay? Now, here I told you, this is an example. If you react with OH, then what happens? This bond will break, it will go as what? Water. Then, this both electrons will be left for carbon atom. Then we will be having CH2, C double bond, CH, H, and negative charge. This is another example of carbanion. Okay? So now let's discuss about the types of carbanion. So in case of carbanion, here also you will be having first degree, second degree, third degree, and methyl carbanion. Types of carbanion. So in case of carbanion, here also again you will be having those 3 to 4 types. So here you have say similar to carbocation, you will be having carbanion. This is tertiary. So this is tertiary. Why tertiary? You know it. And you have CH3, C, CH3, H, negative, CH3, C, H, negative, then C, H, negative. So here, this is third degree carbanion, this is second degree carbanion, this is first degree, and this is methyl carbanion. What tertiary? I told you, this carbon containing negative charge that has related to 3 carbons. Here 2 carbons, here 1 carbon, here no carbon. So here now let's discuss about its stability. Now in this case, this is just a reverse opposite of what? Your stability order will be just opposite of carbohydrate. Why? Because this is having negative charge, and in case of tertiary, there are 3 plus I effect swing group. Now this plus I effect swing group will increase the electron density over this carbon, that means it was already negative. Now it is becoming more negative because of 3 plus I effect. That means more electron density is coming over this carbon. That makes it least stable. So this is our least stable because it has 3 plus I effect swing group. 3 plus I effect swing group. Plus I effect is increasing electron density over the back carbon atom, which is already negative. Therefore, it is least stable. Then comes this is second degree. It has 2 plus I effect. Then you have this showing 1 plus I effect, and here it has 0 plus I effect. Therefore, the stability order is what? Methyl is the most stable, then comes first degree, then second degree, then comes third degree, and it can be explained on the basis of plus I effect. So these are the things that you have to learn from this carbocation and carbanion. Now, free radical, you already know what are free radicals. So about free radicals, we have already discussed the stability of the free radical. Yes, we have discussed free radicals are those compounds where it is formed by homolytic bond fusion and they are deficient in electron. And here also you have tertiary, second degree, first degree, and methyl free radicals, and the stability order will be same as that of what? Same as that of carbocation, because they are electron deficient. Please remember this. Okay? So please keep revising whatever has been taught. Thank you.